So at this time, please go into your Google Classroom and find Mod 56I Day 1. It's solving systems of equations by substitution or elimination. It's the problems that you see here. Now, I'm going to do some of them with you. This should be a review of what you did in an Algebra 2 course. So hopefully it'll just kind of come back to you. The two main ways that we solve systems of linear equations is by substitution and elimination. Now, it doesn't really matter which method you use, but usually they're kind of set up a certain way. So I'm going to do two of the eliminations, and then I'll do two of the substitutions. And then it is your job to finish these in class and turn them in by the end of class. Now, we are looking for the point in which these two lines cross. So what we can try to do is eliminate one of our variables. Now I try to look for the variables that are nicest to get to be opposites. This one's a 14 and it's a negative. I can make this a positive 14 very easily if I multiply through this entire equation by negative 2. So I'm going to do that as a trick so that I can eliminate one of my variables. Now, I could just have easily have multiplied through by negative 4 and got rid of the x's, but this is what occurred to me, so that's what I'm going to go with. So I'm going to get negative 2x plus 14y equals negative 36, and I'm going to put my other equation underneath it. Now, sometimes you'll have to multiply, maybe this equation by 2 and this equation by 3. That's fine. That works sometimes too. But try to pick the easiest route to go. Now, when we add these two equations, if all was right with the world, one of our variables should disappear. So we get 2x. Our y's go away. They cancel out. Equals negative 6. So x equals negative 3. Now, we want the point at which we have an intersection. So now we're going to take this point and plug it into any of our equations. Now, it's totally up to you. I like this nice version here. So I know my x value minus 7 times my y value equals negative 18. So all I did was substitute the x right there. And so I get, if I add 3 to both sides, that negative 7y equals 21. So y also equals negative 3. So please write your answer as an ordered pair. Now, if both of your x's and y's are eliminated and you get a true statement like 0 equals 0, that means that those lines are overlapping. So any set of points that are on that line is a solution. If you get something that's total nonsense, like 4 equals 2, that's one of those lines where those lines happen to be parallel. They have no points in common. So do look for that. Okay, so it's your job to do number 2 and 4. Let's do number 3. I notice that the y's again are very close, just they're off by a multiple of 2. This time I'm going to multiply this equation through by negative 2 so that I can change it to be at 12, but the opposite sign. I need it to be a positive 12. So I'm going to get a negative 2x plus 12y equals negative 8. I get 4x, y's go away, equals negative 8. So x equals negative 2. Now I need to know what y is. This equation seems pretty good. Okay, you can substitute at this point in any equation, but my x value is negative 2, so I get negative 2 minus 6y equals 4. If I add 2 to both sides, I get negative 6y equals 6. Divide by negative 6, I get y equals negative 1 for a point at negative 2, negative 1. Now you can, at any time, you can go into Desmos. You should be able to type in these equations, 6x minus 12y equals 0. And I would always type in the original version. And then our second equation there, x minus 6y equals 4. And you should see their point of intersection is indeed -2, -1. So Desmos, excuse me, is a very good way to check your work. But make sure you can do the algebra and just use Desmos as a check. So that method there is elimination. Please do the other two by the end of class. And then now let's do substitution. Now, substitution is usually a method that, well, it's good. It depends on what you're trying to accomplish. But when one of the equations says either x equals or y equals, so it's explicitly solved for a variable, that means we can substitute this value in that variable spot. So I know that y is equal to -2x plus 6. So as long as I put it in parentheses, I can substitute that in right there. Okay, so let's do that. So I'm going to take the equation that they have told us what y is equal to, -2x plus 6. Sorry, -2x plus 6. And I'm going to put that in the y location. Just again, make sure you use parentheses. Now you have to follow your rules of order of operations and algebra and everything. So let's take this -3 and distribute it. Be careful, you have to take the whole negative with it. And so we get at 8x plus 6x minus 18 equals -4. 14x minus 18 equals -4. I'm going to add 18 to both sides. I get 14x equals 14, or x is 1. Now, one thing I like about substitution is the variable that you find can then be substituted into that really nice original equation for the opposite variable. So y equals -2 times that thing we found, that 1 plus 6. So y equals -2 plus 6, or 4. So that is the intersection at the point 1, 4. Let's do one more substitution, and then you're ready to finish this out by the end of class and turn it in. Now this one I see is ready to be substituted because we've got this. We can take out the y and we can substitute that right in there. Okay, so we know that -2x plus 7 times that y value has to equal 20. So that y value is x plus 5. Now again, if there's a 7 sitting there, we have to use the distributive property. So we get -2x plus 7x plus 35 equals 20. Now just use your rules of order of operations, solving equations. These two are like terms, so go ahead and add those front coefficients. So we get 5x plus 35 equals 20. If you subtract 35 from both sides, you get 5x is -15. Divide by 5, you get x is -3. Now again, we're not done. We have to take that and substitute it back in because we need to know what y is. Now remember, y is your x value plus 5, so it's just that x value plus 5, or 2. That is the point -3, 2. Now the reason we're reviewing this is because on our next lesson, we are going to do nonlinear systems. So we're going to look at systems that aren't lines, maybe a circle and a line are intersecting, a parabola and a line, a parabola and a circle, stuff like that. So we're going to practice the easy ones in this lesson, and then we'll take it a little further next. So it is your job to finish 10 and 12 and 2 and 4 by the end of class and get that turned in. So there you go.